Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, let's talk now. In the previous lecture of CS103, we talked about some of the basic introduction of how programming languages have evolved, what are the basic way you can compile a program, and those kind of things. So in this particular lecture, we'll be talking about some basic elements of C++. I've shown you those basic elements in, or the basic stuff, the very basic stuff of programming, at least in your initial lecture 0, which was on Scratch programming language. In this particular case, I'll be talking about the basic elements of C++, specific to C++ only. And hence, we should, I think, begin with the basic elements of C++. In this particular chapter, the objectives will be to become familiar with the basic components of a C++ program, including functions, special symbols, and identifiers in C++. We want to explore some simple data types. We want to discover how to use arithmetic operators. We want to examine how a program evaluates arithmetic expressions. We will become familiar with the string data type. We'll learn what an assignment statement is and what it does. We'll learn about variable declarations. We'll discover how to input data into memory using input statements. We'll become familiar with the use of increment and decrement operators. We'll examine ways to output results using output statements. We'll learn how to use preprocessor directives and why they are necessary. We'll then learn how to debug some syntax errors. We'll explore how to properly structure a program, including using comments to do documentation to a program. We'll become familiar with compound statements. And finally, we'll learn how to write a C++ program. So what is a computer program? Computer program is a sequence of statements whose objective is to accomplish a task. Programming is the process of planning and creating a program itself. So for example, in real world, a common analogy is basically a recipe for cooking. Cooking itself is something else, but when you plan and how you can make up your food, that recipe is what's a program, a computer program. That recipe helps you to come up with a good food, right? With a good meal. And similarly, the program itself helps you to accomplish a particular task. Okay, so here's a quick look at the C++ program. This is the kind of program that I showed you earlier with a little bit of variation. But so here, what we notice is that there's a preprocessor directive, like I talked to you earlier. And that is like, this is for the compiler. It wants to include the library IOStream for handling the process of the input and output, whatever it is. For that, we need IOStream. Then this is the namespace std, which is within the IOStream. So it's just another directive to use this namespace std. This is also preprocessor directive. Or for the compiler itself, where it can find possible functions here that we're going to use. And you've got a main function. This is the starting function again. Your code, the code that actually runs, is put in here. You initialize or you start with 4 double characters or double variables. One is length, one is width, one is area, one is parameter. All are of type double. Double is usually used when you want to use decimal places as well. So length, width, area, perimeter can be defined in decimals. Then you output. Cout is a command for outputting. Then you've got these 2 braces, program to compute and output the perimeter and area of a rectangle. And then you want to move to the next line, so you use end-l. Finally, in length, you actually store the value 6.0. In width, you store 4.0. In parameter, you store the result of 2 multiplied by length multiplied by width, which are added first and multiplied by 2, and the result is stored in parameter. Finally, area is equal to the length multiplied by width. So first you multiply length and width and store the result in the area. Finally, you output these different parameters. So these are strings. What are strings? I'll talk about them later. But these are just output as they are. So they're in quotes, they'll be output as they are. This one will instead be replaced by the value stored in the variable length. So in case of length, we have variable 6. We'll get length is equal to 6, width is equal to 4. Perimeter is equal to 2 into 10, which is 20. And area is equal to 6 into 4, 24. And finally, we stop the program. All of these are going to be displayed in the next lines. This is basically a quick look at a C++ program. If you want to maybe run it, I think we can try and execute it in a different setting if possible. So let's see if I'm able to explain it to you. If I can find the corresponding program in here, and then I can display it to you. In chapter 2, we want to sample program. Is there a sample program here? No, no, no. We don't have a sample program. Okay. No. Anyway, you could actually, I think, run it and you can come up with a sample program for this. And I think we need to go to the slide again and discuss the possible program here. So yeah, this is how the program looks like. If you run it, you'll be able to see some particular things. This just displays the length, width, parameter, and area, and then exits. It's a program to compute and output the parameter and area of a rectangle, and that's it. So this is a small program. If you run it, you'll basically be getting this particular output program to compute and output the parameter and area of a rectangle. Length is 6, width is 4, parameter is 20, and area is 24. And what's this? If you go into the code itself, you'll notice some certain things. This part, which is represented here in green, reflects the comments. So these are some of the things only for the reader. This has nothing to do with the compiler or with the program. It just helps the reader understand them. And this is a good programming practice. You must always use comments so that whoever else reads your code may be able to get some more help from your possible the explanation that you give for your program using the comments. So comments is for the reader only, for the user only, for the programmer who wants to understand your program. It's a necessary thing. Even for you, sometimes you might forget what you wrote as code a week ago. The comments help you understand and organize your program in a better way. So again, this is something that we're going to discuss later on, and it's not something for now. This is a preprocessor directive. You can let it be as they are. This part is the piece of code that you've written. These are variable declarations, where a variable declaration is a statement which instructs the system to allocate memory space. So here, for example, double length is an instruction to the system to allocate a certain amount of memory. Of course, when you say that some value needs to be stored in length, that value needs to be stored in a particular place, and that place in memory is going to be allocated once it gets the command double here. So that double length is now a place in memory. The name of that space is length, and the possible value it can store is of a type double, because double occupies a certain space in memory. That certain space that's occupied by a double variable, double type variable, is now given to the variable length. Then this is the command that is used for outputting the value. Cout is that command, and it has a particular syntax. We'll talk about it later, maybe in the next chapter. Length is now, you want to basically, this is an assignment statement. You're trying to say that in the variable length, assign the value 6 to it. So the length, wherever it will be used as a variable, it will always have a value 6 now. So the assignment statement actually instructs the system to store a particular value in the memory space length here. So it helps it to store value 6 in the memory space length. Then width is 4, parameter is 2 into this is the same thing, but what is area length into it? This is also an assignment statement. However, in this case, you first need to evaluate the values here. So length, as we can see, value is 6, width, the value is 4. But it takes this value 6 into 4. First, evaluates this value, whatever the final value we get, that is stored in area. So 6 into 4 is 24. 24 is then stored into the area. And finally, these are the output statements that just output the value. An output statement actually instructs the system to basically display results. In this case, the results length, width, parameter, area, etc. are displayed, and this is exactly what happens when you run this program. What is a variable? So I've been using the term variable a couple of times, but now it's the right time to explain what a variable is. A variable is a memory location whose contents can be changed. For example, you see this is a memory allocation of some space to for length, right? Then you have got similarly some memory allocated for width, some memory allocated for area, some memory allocated for perimeter, etc. Similarly, you have got um, in this particular case, actually, when we ran the statement length is equal to 6, after the execution, we can see that in length, a value 6 has been stored. So this is, of course, the value stored in reality is always in binary, but for our understanding, we can think of it as a store where the value 6 is being kept. So this brings us to the second topic, and I'll try to get to the shared screen again before we move on. Yeah, so now you can see the screen again. Some basics of a C++ program. We need to understand what functions are. Functions are, of course, a collection of statements when executed, accomplish something. So what's the difference between a program and a subprogram? Well, a function is part of a program. It's something that is there within a program. On the other hand, you can call it subprogram as well. A program may contain many functions. A function will only contain exactly itself. It cannot hold bodies or definitions of other functions at the same time. It will only hold its own body, its own executable statements. It can call other functions in its body, but it cannot hold bodies or the way other groups of substatements. And a program, on the other hand, actually may contain bodies as well as declarations of many other functions as well. The function, of course, may be predefined or it can be defined by you. So the built-in functions that are already available to us, like cout that we saw, that's a built-in function, and that is available through the libraries to us. On the other hand, there are some standard functions that can be used. Another basic thing for C++ program is this rules, the syntax rules. These are rules that specify which statements or instructions are legal or valid and which are basically not legal and not valid. Then there are some things which we call semantic rules. Semantic rules actually determine the meaning of the instructions. So what does an instruction stand for? What is it supposed to do? That is what we call semantic rule. And finally, what is a programming language? A programming language is a set of rules, symbols, and special words that is used, or that we use, we the programmers or we the users use to accomplish a particular task, or maybe simply to write a program that then accomplishes a particular task. So there are some functions or subprograms, which is just a collection of statement. Then there's the syntax rules. Syntax is like the grammar rules. If you disobey them, then the computer cannot understand what you're trying to do. So these are a set of valid rules and valid legal instructions. What is legal and what is not legal is defined through syntax rules. At the same time, the instructions are meant to accomplish something. And if they are doing that or not is determined by the semantic rules. Semantics and syntax are two different things. And finally, you have a programming language, which is a set of rules, symbols, and special words. You need to remember something. The comments are always for the reader, and the compiler simply ignores them. So you can write them in two different ways. Either they are single line, which begin with two backslashes. For example, this is a C++ program. Welcome to C++ programming, blah, blah, blah. These, whatever is written after this will simply be ignored by the compiler. You can write your own code before it, and along with it, you can put these two backslashes, and then a C++ program. Whatever you write after that, actually, the compiler will not read it. It's for the user, for the reader, not for the compiler. Similarly for this line as well. However, if you want to write multiple lines, then they should be enclosed between backslash steric and steric backslash. So whatever is in between these two will be considered as comments. So, and they need not be on the same line as well. They can be in multiple lines divided in across the line and whatever. Until it does not encounter this statement, it will consider everything as your comment and will not, the compiler will not compile them at all. So maybe I think it's just time that we go to an example to see what a comment looks like. And I think there must be some programs where we have comments. Sorry, I can't find it now. Can I find my program? Oh, yes, I can. Here goes your program. So in this particular program, of course, there is no, okay, yeah, here. So here what we notice is these are all line by line comments. So the author of this particular program is DS Malik. Program make change, give any amount of change expressed in cents. This program computes the number of half dollars, quarters, dimes, nickels, and pennies to become returned, returning as many half dollars as possible, then quarters, dimes, nickels, and pennies in that order. Okay. And then this. So let's say if I remove this, so you can see that these are all, after you've got these two, the rest is all comments. So let's say if I remove this, now this becomes part of the program and this is an error. It's not supposed to be written in here before the preprocessor directives. But if you write it like this, so now this is comment, and here I think it allows you to write as much and whatever in whatever format you want, you can write it over here, because these are all for reader and the compiler does not compile them even. So this is, for example, the header file, the named constants, the declare variable, the statements, step 1 up till step 12, and so on, right? And finally, you return the program. You can actually put them next to the command as well. And in this case, it puts it like this. So these are all comments, right? One way of putting the comments is this way. Another way, if you want to do it, if I just remove this, and then in that case, I finally would want to end it with the steric this. Notice the colors here. So this is really good thing about Visual Studio Code, that it actually helps you to have these colors here. So the green color here is all comments. It's not going to be used. Blue here is a keyword. And yeah, so these are some of the possible code here. In case of comments, and if I don't put this, you will notice that everything here is green now. There's no program actually, and this won't compile. This is going to give an error because this is wrong, unless I actually put this thing, which means that the next is your code. And in this case, this is the ending statement for this one. But we let it be as they are for now. And in this case, this is red. This is not required. We can actually remove it. And I think we are done. So now moving back to the main file, you notice that comments are for the reader. Then you can do it in two ways, and we've done it in exactly two ways. So then there are some special symbols that are reserved that no one else can use. A token is defined as the smallest individual unit of a program that can be written in any language. C++ tokens typically include special symbols, word symbols, and identifiers, and these tokens and words and identifiers, etc., should be totally avoided for naming variables. These are reserved. They cannot be used as names of variables. For example, some special symbols in C++ include plus, minus, multiply, steric, actually, backslash, dot, semicolon, question mark, comma, less than equal to, not equal to, is equal to, greater than equal, etc. So these are all something that have been reserved in C++ for specific tasks. And what are those tasks? We'll come to them in a minute. So when I say some reserved words or keywords in that particular category, these reserved words or keywords are basically symbols that cannot be redefined within the program. You cannot use them, you cannot redefine them. And they can also not be used for anything other than their intended use. They are fixed. C++ only understands their fixed meaning, and it won't understand them for anything else. For example, int is used to store integers or declare integers. And variables of type int will store a value 8, 9, 10, or something like that, any integer in them, even -8, -10, or whatever. So int has a specific purpose, float has a specific purpose, it can store decimal places up to a certain precision. Double has a higher precision than float, it is also going to store decimal points. Char is basically short for character, and it stores single characters. Const is again another keyword or reserved word, which is meant to specify that the value stored in a variable will never be changed. Void is something that is used in functions. Typically, it means that nothing is going to be returned. Similarly, the return statement is used for finally returning back from a particular function. So these are all reserved, and since they're reserved, they can never be declared as a variable name or used at any other place other than their intended use. And when they're used, they'll only mean exactly what they are. They can't be used as names. So what is an identifier? An identifier is the name of something that appears in your program. For example, your variable name is it is an identifier, your function name is an identifier, and so on. So whatever name you'll have in your program, it will be an identifier. So for example, a typical identifier will consist of letters, digits, and underscore character. So it will never ever contain any special characters other than the underscore. You are not allowed to have digit or letter. You are only allowed to have a digit and letter and an underscore in the identifier name and nothing else. At the same time, another limitation or another constraint on an identifier is that it must begin with a letter or an underscore and not with digits. So you can try naming something with digits and it's going to give you an error that that name is not well defined. One thing while we're continuing, I must tell you is that while you're running this whole exercise and code and etc., you can try whatever I tell you using. You can try to run it on your IDE along the way, so that each and everything is kind of crystal clear to you. So that's something that I want you to do. Open up a screen just like I've done, an IDE, and then you need to run it and check all of these. Whether, for example, try and start a variable name with a digit and see what kind of error do you get when you try to compile it, and so on. So having said that, let's come back to the topic here. C++ is a case-sensitive language where capital number is not the same as small number. So that is something that you need to remember. A capital number is going to be different from number, small case number, or even a number beginning with capital N and rest of them small is different from everything in number which is small. So that's one difference. Then there are two predefined identifiers, which is cout and cin. However, these, unlike the reserved words, these predefined identifiers may be redefined, but it is never a good idea to redefine cout and cin. They're used for a different purpose, and let them be for that particular purpose. Cout is for outputting and cin is for inputting. But it's never a good idea to rename them. So let them be always use different names other than cout and cin. So what are some of the legal identifiers in C++? First, does begin with the letter and does not contain any of the special character. It's legal. Conversion, again, is legal. Pay rate contains capital letter, but again, does not contain any of the special characters. So this is legal. So what are some of the illegal identifiers? Employee salary with a space is not allowed. Hello with a with an exclamation mark is a special character which is not allowed. 1 plus 2 plus is not allowed here. Second, it begins with a digit, and hence it is also not allowed. So what are white spaces? Every C++ program contains white spaces. White spaces are typically blanks, tabs, new characters, \n, and so on. These are all typical examples of white spaces. The white spaces in a C++ program are used to separate special symbols, reserved words, and identifiers, and help readability. And exactly that's what is said in the next line. Proper utilization of white space is very important. And if you use it correctly, you might be able to make your program more readable. So you can group your program into a group of related statements into statements that are very different, and so on. So all of this can be done basically if you're using the white spaces correctly. This moves us to the next topic, which is data types. What is a data type? A data type is a set of values that together with a set of operation constitute a data type. So it has got two things. The data type has got a set of values and it has got a set of operations associated with it. So C++, typically data types in C++ fall into three different categories. One is a simple data type like int, etc. that we have seen. The other is a structured data type that we'll probably not see in this course, maybe, but maybe in the coming data structures course, or maybe in the what you call enum, etc. I think when you're introduced to them, you might be seeing a bit of structured data types as well. And finally, you've got pointers, which are part of this course. You'll be introduced to the pointers in this course, but it will be continued on in the next course as well. So if you talk about the simple data types, it is further divided into three further types. One is the integral data type, which is integers that are numbers without a decimal. So for example, you can have char, short, int, long, bool, unsigned char, unsigned short, unsigned int, unsigned long, etc., etc. All of these are basically integers. And by integers, I mean they do not have a decimal number associated with them. On the other hand, you have got floating points, which are decimal numbers. And in this particular scenario, you have got examples like float and double, etc. Then you have got a third type, which is the enumeration type, where you can define what values are to be held as per the whims of the user. And we'll discuss all these three in detail in here. So this is something, again, that you need to be very careful about and understand very well how these data types are defined. So for example, here are some examples. If the data type is int, you can basically have values until -2147483648, which is equal to -2 raised to power 31, because in bytes it takes around 4 bytes, and each byte is basically 8 bits. So in total, it's going to take 32 bits. But since the sign is also involved, minus and plus, the sign bit is excluded. So in total, you have got 31 usable bits. And then the minimum value that you can store is -2 raised to power 31, and the maximum value is 2 raised to power 31 minus 1, since 0 is also included in here. So that's the highest possible value that you're able to store in a int. Boolean, on the other hand, takes 1 byte in memory, and it can only store a value of true or false. A character, on the other hand, also takes 1 byte in memory, but in here the possible values range from -128 to +127, again based on the same rule of sign. And then the maximum value possible that you can store is by using a long, which can store -2 raised to power 63 and until values until 2 raised to power 63 minus 1. It takes 64 bytes in memory, however, for its particular purpose. So if you want to store a very, very large value, the best bet is to use a long. This is something that was asked to you in the mid question as well, and this is something that you need to stay up to as well. So long is something that you can use if you want to store a very large value. Of course, the value stored is just a sample, and different compilers and different operating systems may allow different ranges of values. It depends on the compiler and on the operating system which you're using, and hence this is not the final thing, but this is just a general understanding. In any operating system, in any compiler, of course, the long will always be storing way longer values than an int, and vice versa. Int may be maybe using 4 bytes in memory, or maybe 2 bytes, or maybe 8 bytes, or whatever. That depends on the compiler and the operating system. But in all cases, an int will always be shorter than a long. So typically in int, you can store -6728 078 +763. However, remember not to use a comma within an integer, as commas are only used for separating items in a list, and this is not a list. So this is a number. Do not use comma anywhere in the numbers. The second data type that we discussed is the bool type, which can contain 2 values, true and false. We can manipulate logical Boolean expressions using the Boolean type. For example, if you want to evaluate a particular expression, 2 + 2 is equal to 4, for example, is this true, is this false? Well, 2 + 2 is equal to 4, yes, this is true. 3 + 2 is equal to 4, false, and so on. So these kind of The results of these statements can be stored in a Boolean data type. Boolean can only store the logical values of true and false. However, you need to remember that bool, true, and false are all reserved words. Similarly, if you want to talk about character data type, the char data type, this is the smallest integral data type. This only can store a character. It is used for storing single characters, letters, digits, and special symbols as well. So each character is enclosed in a single quote. If you want to store it as a character, you need to put it in single quotes like capital A, 0, star, plus, dollar, ampersand, etc., etc. All of these signs or symbols or values can be stored into the character value by using single quotes. A blank space is also a character, by the way, which is written like this, with a space left between the single quotes. So a space can also be stored as a character. So different character data sets exist. Of course, the one that we use is the standard now is basically the ASCII character data set, which is the American Standard Code for Information Interchange. It contains 128 values, and each of these 128 values in ASCII code set represents a different character. Characters have a predefined ordering based on the ASCII numeric value. So we have already defined, for example, 65 comes for capital A, 66 comes for capital B, and so on. So each of the characters has been assigned a specific ASCII value, the numeric value, and these numeric values are always, always, always there for each of the data type. And in particular, they are true for any character data type. The collating sequence is an ordering of characters based on the character set code. So we can basically collate the sequence and we can order these characters based on the character set code. The thing that you need to understand for floating point data types is that C++ uses the scientific notation to represent the real numbers or floating point notation. So for example, here is the thing. A decimal number of 75.924 is going to be, the scientific notation is 7.5924 multiplied by 10 raised to power 1. And the C++ floating point notation for representing 75.924 is 7.592400 e raised to power 1. So 10 raised to power 1. Similarly, this is e raised to power minus 1, e raised to power minus 5, e raised to power 0, e raised to power 3. So first it converts to your decimal number, however you want to store it, into basically a scientific notation. And from this scientific notation, it is then converted to the corresponding C++ floating point notation using E for 10. Exactly. So this is how the scientific, the basically real numbers or floating point notations is represented inside the C++ program. So if we talk about floating data points, there are two main floating data type points. One of them is called float and the other is called double. Float represents any real number, but the range, as you can see, is just available for 4 bytes, minus 3.4 into 10 raised to power plus 38 to 3.4 into 10 raised to power plus 38 in total. On the other hand, a double can also represent any real number, but the range is much more. It's basically minus 1.7 e to the power plus 308. Instead of 338, it now goes to plus 308, 10 raised to power 308 to 1.7 e to the power plus 308, and it can store up to 8 bytes of numbers. It takes up 8 bytes in the memory. However, so if you want to save space but aim for maybe low precision, a float is a way better data type. But if you are not worried about space and instead precision, and a much higher precision is required at times, then the double is your go-to data type for some particular tasks. The minimum and maximum values, of course, that are mentioned here are system dependent. You need to be aware of that. In your system, it might be showing a slightly different min and max possible values. The maximum number of significant digits that can be stored, or decimal places that can be stored in float, are basically 6 or 7. On the other hand, the maximum number of significant digits that can be stored in a double are 15. So that's why I can see that the float values are what we call as single precision data types, while the double values are called double precision data types. And by precision, what I mean is the maximum number of significant digits. So of course, 6 or 7 for float and up to 15 for double. So to declare a variable, we must specify its data type. And typically the syntax that is used is data type space identifier. So for example, int counter, double interest rate, car grade, etc. And those are something that you've also seen in the coding examples that I gave earlier. And that's how you determine, you explain or you write out how a typical variable is declared. On the other hand, assignment statements are basically those kind of statements where variable is on the left hand side, followed by an equal to, and then there's some form of expression that needs to be evaluated or that is already evaluated up to a certain number. For example, interest rate is equal to 0.05. Notice that we declared interest rate double as a double, so it's supposed to contain, it can possibly store values like 0.05, and then when you use the assignment statement, it will then store, this is a space in memory by the name of interest rate, and in that memory space you have stored the value 0.05. So what are the different arithmetic operators, operator precedence, and expressions? Well, C++ has different arithmetic operators available. Plus is used for addition, minus is used for subtraction, multiply is used for multiplication, the asterisk is used for multiplication, divide or forward slash is used for division, percent sign is used for modulus or remainder operator. These are something that we've also studied in the discrete structures course, so you're well aware of these. Plus, minus, asterisk, and backslash can be used with integral and floating point data types all the time. However, the percent sign is only used with integral data types, so it's only possible for integers and characters and all those things, but not possible to use the percent sign with the floating data types. You need to keep that point in mind. And while programming, and maybe you can be asked these kind of questions at some point in the exam as well. So for now, it's good to understand that you have got 5 different arithmetic operators: plus, minus, asterisk, divide, and mod. Mod is only available for integers. So when you use divide with the integral data types, the integral result is always truncated. It's not rounded. You need to remember that. So for example, 5 divided by 4 will always be 1. At the same time, 7 divided by 4 will also be 1. So it's not rounding, but it's truncating. You're just discarding the remaining parts of the decimal or the parts after the decimal. So what are the arithmetic expressions? Well, they contain values and arithmetic operators. They are basically equations. They are something that they contain certain values and certain arithmetic operators between them. That's what we call arithmetic expression. What is an operand? An operand, on the other hand, is a number of values on which the operators will work. So the operator are plus, minus, blah, 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 whatever they are. And operands, on the other hand, are the numbers of values on which the operators ultimately work. Operators as defined can be unary, basically maybe just one operand, or they can be binary, that is they are operating on 2 different operands. So for example, the plus sign is generally a binary operand. On the other hand, there can be other examples like mod is also binary, divide is binary, multiply is binary, but maybe some functions and some other things are unary. We'll come to those examples in a minute as well. The order of precedence is also very, very important, I think. Like in maths, you have got this rule which is called BODMAS, bracket, open, divide, multiply, add, and sum. So similar rules exist inside the C++. Of course, all the operations which are inside of brackets first are evaluated at the first, have the highest priority. So brackets have the highest priority, which is then followed by multiply, divide, and mod operators. These 3 are at the same level, and because they're at the same level, they be evaluated from left to right. On the other hand, plus and minus also have the same level, but lower than multiply, divide, and mod signs. And in case they are present, they're not present, then they are finally evaluated at the very end, actually, from left to right. When operators are on the same level, they'll always be performed from left to right. So for example, 3 into 7 minus 6 plus 2 multiplied by 5 divided by 4 plus 6 means that we'll first multiply 3 with 7, then subtract 6 from it. Then we'll basically multiply 2 into 5, then divide by 4, and then add it, and then finally 6 will be added to it at the very end. You can check that on your own as well, how basically this kind of, under these rules, how you get to this particular statement. So what are integral expressions? Well, all operands are integers. They yield an integral result. So for example, if an expression contains only integers, then the result will also be integer as well. So that's an integral expression, an expression which contains only integers. So for example, 2 plus 3 into 5, you'll always get 3 into 5 first, then 15 plus 2, 17. 17 will also be integer. A floating point expression, on the other hand, is a particular expression where all operands are floating points. And a floating point expression will also yield a floating point result. For example, 12.8 multiplied by 17.5 minus 34.5. Again, this is something to differentiate here, that the integral expression will only contain integers, the floating point expression will only contain floating points, and the result for a floating point expression is always a floating point. The result for an integral expression is always an integer. But what about the case where you have got mixed expressions? Mixed expressions have operands of different data types. Some are floating points, some are integers. For example, 2 plus 3.5. The answer is, well, the floating points always take the precedence here, and 2 will first be converted from integer to floating point 2.0, and 2.0 will then be added to 3.5 to give us 5.5 as your answer. Similarly, 6 divided by 4 plus 3.9. Well, 6 divided by 4 is your first part. That results in an integer itself, because integer divided by integer gives you an integer. 6 divided by 4 gives you 1. 1 plus 3.9 gives you 4.9. Notice that being mixed does not necessarily mean that we'll convert to float or integers all the time. If it is possible to use two integers, we will use integers to yield an integer type as a result. But wherever it is not possible, then the thing will be converted to floating points already. So for example, 5.4 multiplied by 2 minus 13.6 plus 18 divided by 2. So if you look at it, multiply has the highest precedence. 5.4 multiplied by 2 gives you 2 will first be converted to floating point 2.0. 2.0 will be multiplied by 5.4, and the answer will be 10.8. 10.8 minus 13.6 plus 18 divided by 2. The next thing is 18 divided by 2. 18 is an integer, 2 is an integer. So 18 divided by 2 gives you 9 as your answer. And then you can move on with it along the way. 10.8 minus 13.6 plus 9. And that's the answer for it. So what are some of the evaluation rules? Well, if operator has same types of operands, so both are either float or both are either decimal point, both are either integers, in that case, they're evaluated according to type of the operands. If it's an integer, the thing will be truncated and it will be resolved accordingly. If it's a float, it will keep up to the precision values and work accordingly. If operator has same type of operands, this is true. If the operator has both types of operands, then integer is always changed to floating type. Operator is evaluated. Result is always a floating point. However, the entire expression is evaluated according to precedence rules. That's the main thing. The whole expression, the precedence is the main thing. If both the operands are basically of the same type, then the rule 1 will be applied. If both the operands are basically of different types, then both of them will be converted to floats, or integer will be converted to float. The operator will be evaluated, and the result will be stored as a floating point. That's just like I told you. Another important thing is, or a concept in C++ is that of type conversion, or typecasting as it is normally called. So what is typecasting? It is the implicit type conversion from one data type to automatically to another data type. So for that, the implicit casting, we basically need to use the cast operator, which provides us the explicit type conversion. Implicit casting is when you can use brackets to convert them. For example, in brackets, you can write int for a float, and the float will automatically be truncated. But if you want an explicit conversion, both work the same way, both have the same result. There's not much of a difference. But in an explicit type conversion, you basically static cast the data type name. So for example, you want to static cast this particular expression into int, you can use static cast int and write your expression over here. We'll see some examples here. So for example, there's example 2.9, which states that this is the expression. Static cast int 7.9. So you want to convert 7.9 into an int. 7.9 to an int is truncated. 7 is truncated. 7.9 is truncated to 7, and result is 7 as it evaluates to it. 3.3 is truncated to 3. 25, you want to cast it to double, then 25 becomes 25.0. 5 plus 3 to double. So first 5 plus 3 is added as 8. And finally, the double cast is applied on 8, which comes out to be 8.0. Then you have got static cast double for 15 divided by 2. So first, the 15 is casted to 15.0 in double. And when you divide 15.0 divided by 2, it's again converted to double. So 15.0 divided by 2 is going to be 15.0 divided by 2.0, which comes out to be 7.5. In this case, it's 7.5, but let's talk about this case. So in this case, it's 15 divided by 2, where an integer is first divided by an integer. So this answers to be 7, and then 7 is then casted to a double. The answer will be 7.0. In the third case, you're trying to static cast int 7.8. So 7.8 is added to a static cast double 15 divided by 2. So in this case, 7.8 plus 15.0 divided by 2.0, which is 7.5. 7.8 plus 7.5 gives you 15.3. 15.3 is then cast to int, so it becomes 15. So the answer is 15. Similarly, for the other example here, first 15 divided by 2 gives you 7.5. 7.5, since it's an integer, it will be truncated to 7. 7 is then cast to double. So 7.8 plus 7 gives you 14.8. 14.8 is then cast to int. So 0.8 will be discarded and 14 will be your answer. So these are something that you need to keep in mind when you're talking about time conversion. This is what happens when you use static cast for various things. So what is a string data type? A string data type is a programmer defined type that is supplied in NC ISO standard C++ library. It may contain sequence of zeros or more characters enclosed in double quotation marks. It may be null or empty based on that is a string that has no characters. Each character has a relative position in the string. So for example, the first position or the first character occurs at position 0, second character occurs at position 1, and so on. So the last alphabet of a string with length n occurs at position n-1. The length of a string is number of characters in it. For example, length of William Jacob is 13 because this is 7. Then you have got a space 8, and then you've got 5 after it, so 13 in total. So length of this particular string is 13. So what are variables, assignment statements, and input statements? Well, data must be loaded into main memory before it can be manipulated or changed. You cannot change the data without loading it into the memory. The storing data in memory is a two-step process where the computer is instructed to allocate memory, and after the memory has been allocated, then you can include statements to put data into memory. So then you need to assign data, you need to put assignment statements such that the data is now stored into that particular piece of memory. So how do you allocate memory with constants and variables? One of them is what we call a named constant. A named constant is a memory location whose content cannot be changed during execution. You want to fix it. You want to name it as a constant after a variable has been named constant. It will not allow you to change its internally stored value. The syntax to declare a named constant is this, where constant, C-O-N-S-T, is the keyword here. Const is the reserved word. You use that. Then you assign you write the data type of it, and then you give a variable name, identifier name, and then the value is then stored into it. Once the value is stored, it will not allow you to change it in any other subsequent lines. Typically, you need to remember whatever you declare as a constant is written in all caps. So for example, conversion, number of students, blank, etc. Everything is written in all caps. This is to distinguish them from non-constant variables, and this is a good programming practice actually. So you must, it's not necessary, you can actually declare a constant without using caps as well. That will run absolutely fine, but it's not a good reading or good programming practice. In programming, such a kind of behavior where you write all caps, for example, for pi or for anything else, is used to declare constants that cannot and should not be changed actually during the program. The const only guarantees that the value will not be changed during the execution of the program at all, at any place, by anyone. So what's a variable? A variable is a memory location whose content may change during the execution. As the name suggests, constant is something that is constant, its value is not allowed to change. A variable, on the other hand, is a memory location whose content may change during execution, and we should look into it. The syntax to declare a named constant is basically this: data type, identifier this, and blah, blah, blah. And this is something that we've done already. For example, double amount due, int counter, car ch, int x comma y. So here we're declaring two different variables, x and y. We can use the string in a similar way, string name. Notice that string with the small s is different from string that starts with capital S. String is a reserved keyword, but the other string kept with capital S is not reserved. So it's a different, it can be used as a variable name as well. But the one with the small s cannot be used as a variable name. So how do you put data into variables? Well, there are two main ways, or maybe multiple ways, but there are two ways to put data into the, or place data into a variable. First is to use the C++ assignment statement, which is you use equal to sign, and then you can put in any value into it. Or the other is to get it directly from the user by using the input or read statements. It can be from a file, from the user, from some other place, but you just read some stream and you're able to identify and you're able to put in the values. What is an assignment statement? An assignment statement takes the form variable is equal to expression. So you have an equal to sign, you have got a variable on the left hand side and an expression that needs to be evaluated, and whatever the answer to that expression is will be stored in the variable. So expression is evaluated and its value is then assigned to the variable on the left side. That's what I said before. A variable is set to be initialized. So that's one thing, you might be getting the initialization error and in certain IDEs and compilers. But how do you initialize a variable? And a variable is set to be initialized the first time a value is placed into it. So if you do not place a value into it and you try to access it, that is where you're going to get an initialization error. In C++, the equal to sign is called the assignment operator, and it basically is the one that assigns the value on the right-hand side to the left-hand side variable. So this is used to store the variable. It's going to assign the value to the left-hand side. So for example, here, if you go to the example 2.13, you may have the following variable declarations. You have declared the variable num1 and num2 with int, double sale as double, first as a character, str as a string. Now, if we consider the following assignment operators, num1 is equal to 4. So this means that the value 4 will now be put into num1. The second statement suggests that 4 multiplied by 5 minus 11. If you evaluate it, 4 into 5 is 20, 20 minus 11 is 9. So the value 9 will be stored in num2. For the third one, you have got sale. Sale is basically a double, and that 0.02 multiplied by 1000, which comes out to be 20. If I get it correctly, and 20 will then be 20.0 will actually be stored in sale. Then you have got a character first where capital D is going to be stored, and finally string str is going to store it is a sunny day. So how do you save and use the value of an expression? Well, to save the value of an expression, we first declare a variable of the appropriate data type. For example, in the previous case, we use string or character or whatever. So you need to declare a variable of the appropriate data type, and then use the assignment statement to assign the value of the expression to the variable that was just declared. So wherever the value of the expression is needed, we can use the variable holding the value by its name directly, and that variable will actually give us the possible value of the expression, which has been evaluated already. So how do you declare and initialize variables? Well, there are multiple ways of initializing and declaring variables, but what you need to remember is that not all types of variables are initialized automatically. It's not an automatic process for all types of variables. So the best way to do is to initialize the variable maybe when they're declared right at that time if it is possible. For example, int first is equal to 13 and second is equal to 10. It's a single line and both the variables have been initialized. Char ch is equal to quotes, this is also initialized. Similarly, double x is equal to 12.6 is also initialized. But the limitation here is that whenever you want to use a variable, the variable must have been initialized before it was called for usage. If that is not the case, it will give an error. But if you are not just, you're not declaring it at the time of, you're not initializing it at the time of declaration, but you might assign it possible values at a later stage, still it won't be a problem. It's not necessary to initialize during declaration, but you can always initialize it at any point in your program. So how do you read statements from the user? And I basically gave a small example earlier on where I used cin. I showed you that. Here's a formal way to introduce cin to you. Cin is basically a reserved word that is used along with the greater than sign to gather input. So for example, cin, you put that sign, then variable name, then again put these brackets, variable2, and so on. So this is what we call an input or read statement. And these sign, this is what we call the stream extraction operator. This is extracts the value from the stream and puts it into this particular variable. For example, if miles is a double variable, then by writing this, it causes the computer to get a value of type double and place it into the variable miles. So this is going to, the program is stopped there, as you saw, and until you don't enter a value for a double value for miles, it's not going to enter it. You can enter a non-double value as well, but in that case, it will be converted to double and then put in there. If it's not possible to convert, it's going to give an error that the value entered here was incorrect. So if you use more than one variables in cin, that allows for more than one variable to be, or one value to be read at the same time. For example, if you want to read feet and inches, which are variables of data type int, then this statement cin feet inches is going to input two integers from the keyboard. So maybe if you can write the value for feet, put a space, write about inches, and it will automatically place them in variables feet and inches. Otherwise, if you try and write two values for just one cin with space, it is going to neglect anything that comes after space for the particular case. But if you want to store both of them, you should write it like this and then use space to differentiate between them. So this is the example here. Int feet, int inches, enter two integers separated by one or more spaces. And here you can see that we have taken both of them at the same time. Then we can basically just output what is feet and what is inches value. And sample run for this case is going to be enter two integers separated by one or more spaces. So for example, the user has entered 23 space 7. This is the shaded part. 23 space 7 means that now the computer can basically read that the feet is equal to 23 and inch is equal to 7. So it is able to understand that two different inputs have been provided to it. So what's the increment and decrement operators? These are two more operators that are unary operators, and that's what I was talking earlier about. This only requires one variable. And the increment operator, for example, increases the variable by value of 1. So for example, if you pre-increment it, that is, what is pre-increment? Pre-increment is a specific operation in which the variable value is first incremented and then read. So the value, whatever is stored in variable, is first incremented and then read. So for example, let's say, we'll see the example later on, I think in the later part. Similarly, the post increment is where the variable is first read, and after reading it, the value is then incremented. After execution of the statement, the final step in the statement is to increment the value of variable. So similarly, you can define the decrement operator, which increases the variable by 1. The pre-decrement operator is minus variable, and the post-decrement is variable minus. Pre-decrement again first decreases the value of the variable and then uses it or retrieves the value. On the other hand, the post-decrement actually first retrieves the value first and then decrements it by 1. So what is the difference between the following? That's a question for you. If x is equal to 5, then y is equal to plus x. And if x is equal to 5, y is equal to x plus plus. What is the value of that will be stored in y in the first case, and what is the value that is going to be stored in y in the second case? Maybe you can pause the video here, think about it, and after come back for an answer in a second. Okay, so I think you have already got the answer. In the first case, we see that it's a pre-increment. So first the value of x is retrieved. The value of x is 5. It is stored in y. And then the value of x is incremented. So now after this particular statement, the value stored in y is 5, but the value stored in x is 6. In the second case, we notice that it's a post-increment operator. So first, we see that the value of x is retrieved first. Sorry. The first is pre-increment. Since the first is pre-increment, that means that the value of y is 6 as well as the value stored in x is also 6. In the second case, it's a post increment operator. And in that particular scenario, it's going to be y is equal to 5 because the value 5 is currently stored. And then after the value 5 has been retrieved and stored in y, only then will the value of x going to change to 6. So x will finally have the value 6, y will have the value of 5 in the second case, while in the first case, the value x will have the value 6, but y will have the value, so y will also have the value 6. So that's the difference between these two. 6 and 6 in the first scenario, and 6 and 5 after you execute this particular statement. The output, for output again, if you want to display us a line or something, the syntax, the cout command is used along with the stream insertion operator. The statement cout is called basically an output statement, where we notice that we can either have an expression or manipulator followed by another expression or manipulator and so on, using the stream insertion operators throughout. The expression evaluated and its value is printed at the current cursor position on the screen. So wherever the cursor is, the expression that is being evaluated and its value will be printed on the current cursor position. So for example, a manipulator may be used to format the output. For example, typical manipulator is what we call endl. Endl causes insertion point to move to beginning of next line. So it's something that moves it to the next line. For example, cout 29 divided by 4, and then you've got the manipulator endl. What happens here is that we output basically 29 divided by 4 is by rule 7.25, but since these are both integers, we'll get 7, and after printing out 7, it goes to the next line. Then cout hello there point, this is a string that needs to be printed as it is, followed by manipulating it to the next line. Again, hello there will be printed, followed by going to the next line. Finally, you want to print out 12. 12 is an integer as it is, and then go to the next line. So 12 will be printed and move to the next line. Then you've got cout 4 plus 7 in quotes. So this is a string. This is not supposed to be evaluated, but put out as it is. So 4 plus 7 will be printed as it is, and then we move to the next line. So in this case, in case 5, we have got 4 plus 7. This needs to be evaluated. These are both integers. 4 plus 7 is 11. So 11, and finally move to the next line. You want to print a character A only. The character A is printed. You want to cout 4 plus 7 is equal to, again, a manipulator, 4 plus 7, and then an endl. So this is going to print out, this is a string. 4 plus 7 is equal to, will be printed as it is, along with spaces. Then these ones are going to be added, and answer is 11. So 11 will be printed, and finally move to the next line. Similarly, for this, 3 multiplied by 5 will be performed first. 15 plus 2 is 17. So 17 will be printed, and then finally the end of line. Notice the special characters \n here. Backslash introduces special characters here. \n is to put the cursor at the next line, just like an endl. And in this case, you're going to print hello space next line there. Full stop, and that's it. So these are some of the things, somehow the output should look like. The new line character that we just saw is \n. It may appear anywhere in the string. What it does is it puts output to the next line. For example, cout hello there, cout my name is James. The output is going to look like hello there, full stop, and directly start off my name is James. However, if you put a \n at the end of hello there, then in this case, the top line would look like hello there point. In the next line, we'll have my name is James, and that's it. So that's the difference that \n brings to on the table for cout. When you use a backslash, backslash is what we call escape character. And it is used to signify some special escape sequences. Some of the commonly used escape sequences are given here. For example, \n is the new line escape sequence, which is used for the cursor to move to the beginning of the next line. Similarly, \t is used for tabbing or tab. It moves the cursor to the next tab stop, whatever that is. Similarly, \b is used for backspace. It moves the cursor one space to the left. Similarly, \r is the return escape sequence. In case of \r, the cursor moves to the beginning of the current line, not the next line. So the same line, it moves to the beginning of the current line. Double backslash is basically, if you want to print a backslash, you'll be using a double backslash. It prints a backslash. If you want to print a quote, a single quote, you can use backslash quote. So again, it acts as an escape character, and a single quotation mark is going to be printed. If you want to print double quotes, you're going to use a backslash double quote escape character, escape sequence. In this case, a double quotation mark is printed. Then we come to another important topic that I had so far skipped, and that is the preprocessor directives. What is the preprocessor directive? It is in C++, we have a number of small number of operations. Many functions and symbols need to run a C++ program are provided as collection of libraries already. So you don't need to reinvent the wheel completely. In that case, a lot of code has already, and a lot of things have already been done for you. You just need to include them into your program. You just need to include the library functions, where every library function has a particular name and is referred to as by a header file. So the name and the header file, you just need to include them. A preprocessor directive is basically a command that is given to the preprocessor program. When it is given to a preprocessor program, the preprocessor will automatically include them along with your code so that your program can execute and use functions or piece of code from the other program. All the preprocessor commands always begin with a hash symbol. And remember that there's no semicolon at the end of these commands. So our typical program that we have seen, every single statement ends with a semicolon. That is not true for the preprocessor commands. They never end with a semicolon. They don't have a semicolon at the end, but they must begin with a hash symbol. A hash symbol is used as a preprocessor directive. And they usually put up at the top of the file. That's also something that you need to know. For example, how do you include a header file? A header file you can always include by include header file name. For example, hash include iostream that you have seen earlier causes the preprocessor to include the header file iostream from the library into the program. The preprocessor commands are processed before the program goes through the compiler. So these are something that for the preprocessor to identify, process, and put through before the program can actually go into the compilation phase. So what is namespace and using scene and cout during a program? First thing is that when we use scene and cout, they are declared inside the header file iostream, of course, but inside the header file iostream, there are further many different namespaces that are used. You can think of it as a main set and subsets. So scene and cout is within the std namespace or within the std subset of the set main set iostream. iostream is the input output stream file, as we call it. iostream is the name of it. So iostream, within that, there are many different other small subsets. One of them, the subset is std. And if you don't have std, you cannot use scene and cout, because just by including iostream, it still will not be able to identify which subset was called, which subset is used, which contains scene and cout. To use scene and cout in a program, we need to include the following two statements. First of all, we need to include the main subset, main set, which is the iostream. And then we need to include the subset which contains scene and cout, which is std. So we can include that by using the command using namespace std. Again, this is something for the compiler. The compiler reads using namespace std, and then it can get the relevant file. So the string data type, if you want to use that in your program, you will need to include a particular header file called string. You can include it using the preprocessor directive hash include string, and then you can use the string data type in your program. So how do you create a C++ program? A C++ program is mainly a collection of many different functions. What are functions? We'll probably study in a little while. But one of the most important functions in a C++ program, and which is a mandatory one, is also called main. So that's the function main is one of the major functions of C++. A C++ program itself is basically a collection of many different functions, at least one or more functions, of which main is the main thing. The first line of the function main is called the heading of the function. We always declare it like this, int main. The statements enclosed between the curly braces form the body of the function. So if you go back and look at the function main in the example, you'll notice that it always, we always enclose braces and form the, whatever is written inside the braces will always be executed, and that's the main body of the function. A C++ program contains two types of statements. One of the statements is what we call declaration statements. They just declare things, for example, variables or something. And the other part is executable statements. These are the statements where the actual calculations are performed, where the data is manipulated or changed or modified. These are the statements which create output, so they convert your input into your output. They can accept input, etc., etc., etc. So these are executions. Then there are some declarations. Declarations declaring data types and the basics of your C++ program. If we talk about the program itself, of course, a typical C++ program has two main parts. One is the preprocessor directives, as we have seen, and the other is the program. You must always remember that the preprocessor directives that you write at the top and your program statements together constitute a C++ source code, which is supposed to be saved in a .cpp file. Your compiler then generates the object code or .obj from your source code when you execute it or when you want to run it. And that final obj files can then be executed. And they have a specific extension after the compiler actually has run, the linker has run, the library has been added, everything is ready. You then get an executable file or executable code, which is then stored with an extension .exe. So sometimes the compiler generates an obj code, and then it when an .exe file is finally created, the obj file is finally deleted. So you might just see .cpp and .exe file in your folder, but in reality, it's always like the .cpp is first converted to .obj by the compiler, and then the linker and the loader actually adds the remaining part of the library files into your code to create the final executable chunk, which is the .exe file, and the loader then loads this exe for execution into your memory. How do you debug a program? That's the main thing. Debugging is a process of understanding and fixing some syntax errors in the program. So when you compile a program, the compiler will identify some certain syntax errors in your program. It specifies the line numbers where the errors occur. For example, if I run example2 underscore syntax underscore errors.cpp, I might get an error in C chapter 2. That's a place where, and the file name is example2 syntax errors.cpp. On the 9th line, there is some error such that C2146 is a syntax error. It is either missing semicolon before identifier num. Similarly, another error that is observed on line 11. The error is C2065, and it's specifically related to temp num, which is an undeclared identifier. And we'll get to through it soon at the end of this lecture. So one thing that you need to remember is that you need to have good programming practices for your programming style and form, and you should follow the syntax rules as much as possible. The syntax rules are rules which indicate what is legal and what is not illegal. The errors in syntax are found in compilation typically. So whenever you're compiling, if there's an error, it's going to give you out. For example, when you compile this particular program, it's going to give you an error on line 2 and line 4. In line 2, the error is that y is not int y, you're not ending with a semicolon. So this is a problem. And finally, in line 4, the error is that the variable w has not been declared before. So it cannot perform its addition, and hence it cannot determine the data type either or anything. So this is not going to compile at all. So this is some of the syntax errors that are caught right when you compile your program. Remember that whenever you're using, you're writing a program, you can always use blanks as much as possible. There is no problem with them. Blanks actually help improve readability of your program. They're not used at all. Blanks may also be used to separate some reserved words and identifiers from each other and from each other, the symbols, etc. But remember that whenever you are using a reserved word or identifier, they must not contain any blank. Semicolons, brackets, or commas are again some of the important things. You should all C++ statements always end with a semicolon, except for the preprocessor directives that you need to remember. Also, these are called, the semicolons are called statement terminators. The braces, the braces that are shown here are not statements as such, but they can be regarded as delimiters. They basically define which block of code belongs to a particular place. So if you have multiple statements, these braces may define that, okay, all these statements within these braces are part of this particular piece of code. And similarly, commas are used to separate items in a list. So that's another important thing. Then if you talk about semantics, semantics are the set of rules that give meaning to a language. So for example, it may be possible to remove all syntax errors in a program and still it will not run as you intend it to. And even if it runs, sometimes it may still not exactly do what we want it to do, what it was meant to do. For example, if you write out 2 plus 3 into 5 and if you write in braces 2 plus 3 into 5, they're both syntactically correct expressions, but both give a different result in their answers. And because both have different solutions, so both of them will be giving a totally different answer. And they may not, if you write the first statement or the second statement, they may not exactly do what they were supposed to do. So the naming of identifiers is something that is very important. You should always name an identifier to be a self-documenting one. That is, without documentation, you should be able to understand what it means. For example, if you write centimeters per inch, it's understood that it is going to store some kind of centimeters per inch criteria or value. And when you write it in all caps, I've already told you this is fixed. You want it to be a constant. And yeah, in 1 inch, if you've got 30 centimeters or something, then this is fixed and you don't want to change it. You should avoid run together words. For example, annual sale should be avoided as it is written here. Some solutions for that is that we should capitalize every new word. For example, in annual sale, the next word sale should be capitalized. The other ways to insert an underscore maybe just before the next word is used. So annual underscore sale is also a good way of writing or naming an identifier. Then there is something which we call the prompt lines. The prompt lines are always used whenever we want to get some input from the, whenever we want an input to be entered from the user. The prompt lines are executable statements that inform the user what it needs to be done for the next thing. So if you don't write cout, please enter a name and then press this and do this and do that, then the user might not actually know what to do. So you might just enter a number and do not press enter. Or the user might just say something and it's not clear what needs to be done. Sometimes you don't write cout and you directly write c in statements. That is an absolutely not recommended for you. You should never ever write scene alone. It must always be accompanied by a cout statement which clearly states, please enter a number for this particular purpose and then press the return key to save the value. So that the user is very, very clear what needs to be done here and what is being asked for. So that's another important thing. Prompt lines are important and they must be used accordingly. Finally, you need to document your program as much as possible. A well-documented program is easy to understand and modify as well by other people. And by you as well in the later stage. You can use comments to document your programs. Comments should not be added without any purpose. There is some purpose of adding a comment. It's not a random purpose. It's not like you say, hey, hi, how do you do? You know, those kind of things. A comment must serve a purpose. What's the purpose of a comment? It should either, if you write it at the top, it's to explain the purpose of the program overall. It should identify who wrote it, like I showed you for DS Malik. And it should explain the purpose of particular statements at times. So this is step one. Step one performs this particular statement. Step two performs this. Step three performs this, and so on. So it should explain the purpose of a group of statements or even a single statement at times. So this is what a comment should do. It should not be irrelevant. It should not be put in without any purpose. They must serve some certain purpose or explain some certain things. So let's consider this. There are two ways of declaring variables. One is that int feed comma inch semicolon double x comma y, or put them together in the same line. If you run both are going to run fine and perform exactly as they are intended to do. But the problem is that despite them being corrected, the second one is much harder to read and much harder to relate to. So it's always preferred that you use the first way, where similar things are grouped together, different things are grouped in are put into the next line, tabs are used properly, and proper coding has been done. So if you want to use assignment operators or assignment things, there are two forms of assignment. One is simple and the other is compound. The compound operators provide more concise notation. For example, they are more concise, but they may, cause more, they may be harder to read and at times may confuse people. So for example, The compound of the simple operators are x is equal to x multiplied by y as a simple example. On the other hand, a similar compound statement that performs exactly the same thing would be x multiply equal to y. They are both equal, they produce the same result. Similarly, there are other compound operators like plus equal to, minus equal to, multiply equal to, divide equal to, or mod equal to. And by that, we always mean that we want to store this result into the same variable. So this is x is equal to x into y. This might be x is equal to x plus y, x is equal to x minus y, x is equal to x multiplied by y, x is equal to x divided by y, and x is equal to x mod of y. So to summarize the whole lecture quickly, I think it would be that a C++ program is a collection of functions, one of which is always called main. The identifiers consist of letters, digits, and underscores, and begins with letter or underscore. The arithmetic operators in C++ are addition, which is plus, subtraction, which is minus, multiplication, which is multiply, asterisk, division, which is a backslash, and finally modulus, which is a mod, percentage sign. Arithmetic expressions are evaluated using the precedence associativity rules, that is from left to right, or basically first the BOD mass is applied, and then if two operands have the same, operators have the same precedence, then they are associated, then they are evaluated from left to right. All operands in an integral expression are integers. In a typical integral expression, everything is integer. All operands in a floating point expression are basically decimal numbers like float and double. In a mixed expression, it may contain both integers and decimal numbers. We need to use the cast operator to explicitly convert values from one data type to another. A named constant is initialized when declared. So a named constant is always initialized when it is declared. All variables must be declared before they're used. Use the cin and stream extraction operator this to input from the standard input device, or basically from the command line from the user. And in the other case, we need to use the cout and stream insertion operator to output to the standard output device, which is usually your monitor, or it may be the projector or whatever. So yeah, that's the way the output is going to go, or it might also go to the file depending on how you use the cout. The preprocessor commands are processed before the program goes through the compiler. So that's the thing. The preprocessor commands are there for to be processed by the preprocessor before the compilation phase is started. A file that contains a C++ program usually ends with the extension .cpp. You need to remember that a .cpp is a file that contains a C++ program. So that is all about chapter 2. In the next lecture, we'll start with chapter 3 and probably go through it in a single lecture again. So I hope you've learned some basics of C++ program. I'll now quickly go through some of the examples, just execute them one by one and maybe discuss them a bit as well for a better understanding of each concept that we have discussed here. This is going to help us in the next slides. So let's say if I now go to my code, and in the code, I can basically see a few of the programs. Let's go to convert length program. This is my convert length program. Again, you can see these are some of the comments here given by the user. This identifies who the author is, what the program does. That's all. And that's the only thing that is required for these particular comments. Then this is the header file section, which includes the IOStream header file. And then it used the subgroup inside IOStream, which is std, to identify cout and cin. This is something that is almost always present in all the codes. Then you've got some named constants, and if you see this particular example, you see that the constant double is named, since this is a constant value, we see all caps here, centimeters per inch, and you store a value right here along with it. And if you see the value stored here is actually 2.54, couple of zeros and 36. So this is a problem with the precision. But so you should, if you use the equality operator that we'll study probably next, we'll talk about this in the next chapter, I think, or chapter 4 to be precise. But so here we see that again, inches per foot is again a constant. It is an integer, and the value 12 is stored exactly into it. And then if we move into the code, this is the main function. This is always declared as it is. And then this is your code that you want to run. So you want to get some feet inches, total inches. Notice that it uses a capital I here. to differentiate. These are two words, but using a capital I, it is a tab to show that this is the next block. For each block, it is using a tab, etc. Right? And this finally just displays or inputs or does things that are exactly there, and finally it quits. Here is where it is computing some value, and it is going to quit. So if we run this code, you can see that a new file was created, chapter2_length. This is your executable file. Enter two integers, one for feet and one for inches. So let's say if we enter 23, and let's say if we enter 10 for inches. The numbers you entered are 23 for feet and 10 for inches. The total number of inches are 286. The number of centimeters in there is 726.44. So it just use the formula of inches per foot, which is it fixed at the top to 2.54. So there are 2.54 centimeters in a centimeter, and similarly, the number of inches in a foot are 12, and they just use them as they are to compute these particular values, and it has finally quit. So this is the first program. Then let's talk about makechange.cpp. So makechange.cpp is a program that, given any amount of change expressed in cents, this program computes the number of half dollars, quarters, dimes, nickels, and pennies to be returned, returning as many half dollars as possible, then quarters, dimes, nickels, and pennies in that order. And you can see again the code here is, this is the command for the reader. The compiler is not going to read it. There is a header file for the preprocessor. Then there are some named constants here. Half dollar is 50, quarter is 25 cents, dime is 10 cents, nickel is 5 cents. So declare a variable called change. You're going to perform these steps. The statements are going to be entered from step 1 to 12. And if you go on one by one, it basically runs something and does something. Let's just run the code and see what it does. Okay, it says that makechange.cpp, it wants to identify, it cannot find some certain files here, which is change2_make_change.cpp change. Why is the change file not here? I'm not talking about int change, scene change. Okay, something is weird here. It should be able to compile it. I don't think so. There is, or maybe there's some problem with the name change here. Okay, this should compile as it is, or maybe change is a keyword. So it's int change is mentioned here. Okay, I think no such file or directly no input files. You're supposed to read from a file? No, it's going to read from cin. Okay, something weird is happening. Anyway, let's go to third example and let's just execute it as well. I'll probably come back to this example soon, but if you run the third example, this program, there's no mention of what it does. You want to enter the radius, and yeah, so similar things. I'm getting errors here. I think I modified those files. This one should run, and we should output the length and code. There are two warnings here, but it is at least running, giving us a value 6, 4, 20, 24. This was the exact program that you saw before. And 7 and yeah, so this is kind of for length 6.99, which is an int. It would convert it into 6 and execute it. I showed you in the class as well, and these are something from there. So let's go to example this, and in this case, these are the rules that will be followed. 2 plus 5 is equal to 2 plus 5.5. You can see different rules and how integral expressions are evaluated. This is for evaluating integral expressions. We can find different values here, and this again, you will run through and try to make sense of them. Let's go to 2.4 modified, which is given length in inches. This program outputs the equivalent length in feet and remaining inches. And total inches are, let's say, 128. This is basically 10 feet and 8 inches and so on. So this works on that front. Then if we go to 2.4, this is basically storing 100 inches and converting 100 inches into feet. And yeah, so 100 inches are converted to 8 feet and 4 inches. If we talk about example 2.5, this again this is basically for the illustrating how arithmetic operators work on floats and on decimal operators, integer operators. So here again, you've got different answers for different operators, and these are what they are. Then if you go to example 2.8, I think here again, this is how the program works, how the mixed expressions are evaluated. And these are the results that you get for mixed expressions. Again, you can just evaluate them and see the results, etc. Let's go to example 2.9. Example 2.9 is how illustrating how explicit type conversion works. So this is explicit type conversion where we're trying to convert to int, double, etc., etc. These are all examples. Again, if we run them, we'll get some values after conversion. I showed you how this works. And when I was running the things, let's go to this example. So this is a program that illustrates how data in the variables are manipulated. These are already, all these programs have already been uploaded on the Google Drive link that I shared with you. And again, these are how the different data in the variable are manipulated. So let's go to 2.17 and let's just run this one. This program illustrates how input statements work. So how cin works. It wants two integers that are separated by 1 or 2. Let's go for 12 and let's go for 10. And this is the number of feet and inches that are going to be stored. Let's go for 2.18. This program illustrates how to read strings and numeric data. So this is a program that is going to read strings and numeric data. So these are two strings, first name and last name, and then numeric data as well. So if you want to store the first name and last name, you're going to use cin this. Then you need to enter two numeric data and age and weight and see how it runs. If you execute it, we can basically enter the first name as Hashim, second name is Ali, age is 25, weight is, let's say, 90. So now it says that the name is Hashim Ali. See, there was a mistake there, so it is entered exactly in the same way. Age is 25 and weight is 90. So let's talk about 2.19. And this, they have not written what it does, but it says that when prompted, enter the following data and press the enter key. So cout, you need to enter this one, right? Count, and it does something. We need to see what this program is doing, right? So let's just execute it and let's see what happens. So when prompted, enter the following data and press the enter key. So we need to enter 10.5, 4.0, MEA. And this is, it performs something, it counts them, does length, width, area, it does something, and finally it gives us a result. So maybe it's doing something, I don't know, whatever it is made for, it is made for a particular purpose, it does it, and then it exits. So here's another program which illustrates how the output statements work. So this is for output statements. If you just run the code, this is all cout statements, and they are basically going to show how the different output statements and precedence, etc. work. That's the best way for this. Okay, and then here's a program which shows the effect of escape sequences. Again, if you execute it, this kind of shows how different escape sequences, the backslashes here work. So backslash n is this is going to be the new line escape sequences, backslash n is going to be printed out exactly. The tab character is represented as backslash t. The tab character is represented as quotes backslash t. So you want quotes in backslash t. The tab character is represented as, again, you have got a quote backslash t as a tab. And yeah, so this is an escape character followed by backslash t, followed by a single quote, followed by, yeah, so yeah. And finally, you have got the string sunny in quotes, double quotes, contains 5 characters, 1, 2, 3, 4, 5. Yeah, so that is also what you get over here. Let's go to the next example, 2.29, and this is basically the program shows where the include statements, using statements, named constant, variable declarations, assignment statements, and input and output statements typically appear. And this is what you want to say. These are basically your declarations. You've got named constants over here. See, this is all caps. So this is something that I talked about earlier. And then you can basically use them, do them, yeah, work with them and learn about them. So here it gives that basically first number is equal to 18, line 10. It says that enter integer, let's call it 12. So the second number is 12. The new value of first number is 54. and then it quits. So it does its work and then it quits. So let's about this particular program, which is an improperly formatted C++ program. So there's something wrong about the formatting here. What's wrong? Multiple things here are that there must be tabs here. So this must all be tabbed. There cannot be two statements in a single line or two or more statements like this. These tabs are incorrect again. Yeah, multiple statements on the same line. There should be some spacing here. Spacing helps you to improve readability. Spacing here as well. Spacing here. So constant spacing problems and constant naming, and even these ones can be put out as a separate cout line. That would be a better option. And these in a separate line, etc. So all these kind of things make this program a really improperly formatted program. Although if you run it, it will run like a charm. There's no issue with the program, right? But the way it's written, it's really poorly formatted. And this is something that you should avoid at all cost. So let's go to example B. And this is the same program which is properly formatted, and you can see this is beautifully written. You can read it out, you can understand what's going on, and it becomes good for me as well as an evaluator to evaluate your programs. So if you don't follow it, believe me, I'm going to give you 0 marks for your program, even if it works absolutely correctly. I believe that you should always write code in this form. So if you do the same code, for example, you enter the height, enter integer, enter whatever, and it does. And it's basically working out really well. So enter integer here is 12. Enter the first name, Hashim, enter the height 12, and that's what it gives. Okay, so yeah, this works like a charm. Let's say these are something that you need to do. This is a program where there are some form of, I think, syntax errors that are present. Yeah, this is the program. So there are some syntax errors here and you need to correct them. So for example, in this case, there's a semicolon that is missing here. Number is equal to 18 is fine. Temp num is equal to num is also fine. Ending with semicolon, cout num temp num is equal to temp num endl, and this is fine. So if I compile it, if I run code, I'm going to get a syntax error that says something wrong in return. There's an error in non-void function main, and then there's a temp num. This temp num is there's something wrong with this single braces. So you see there's a single braces that should be double. It points out all the possible errors that are there and gives warnings as well to what needs to be done. And I think that's about it for this one. So if you correct them, it looks something like this, and this is going to run out. If you run this code, it runs fine. It basically gives you the number 18, temp num 36, etc., and gives you those values and runs fine. Then if you talk about 4 even numbers program, this was something that I did for you in the class. It takes 4 numbers, and if one of them is even, it stops. Otherwise, it keeps on asking you until next even number is given. And finally, there's this if-else statement. I think this is coming in the next few chapters. So yeah, the 4 numbers and even numbers cannot be considered for now, but all others are examples of the same chapter and should be considered for you. So that brings us to the end of the chapter of this particular chapter 2. I hope you've learned some of the basics and some of the basic ways you need to program, some of the good programming practices. I showed you the examples of the chapters at the end so that you can kind of go through them and come up with some form of really nice programming solutions and basic programs that you need to do. This helps you get your basics right. What is allowed, what is not allowed, what is the syntax error, you need to be working on it from this particular perspective. So, and you saw how to make up a C++ program from the scratch, and you should be able to do it on your own as well now. With that, I'd like to thank you all for listening to this relatively long lecture. I hope that you've understood what programming is and how it's done. And I really wish you all the best so that you're able to start programming on your own. The first thing, of course, is to get an IDE ready on your own computer. And for each of these examples, you need to run, understand them concretely. Only then will you, and maybe even try to come up with your own solutions or own small problems that you can solve. Okay, thank you. Take care and see you in the next lecture.